Hello, Assalamualaikum. My name is Muhammad Nasrullah Fazil. We from Group 2 Section 1, we will present about our project. Okay, this is our group member. Is firstly is Adila Fariha binti Zainal. Second is Amsyah Fahmi bin Asmadi. Third is Muhammad Afiq Izzuddin bin Syahrir. Fourth is me, Muhammad Nasrullah Fazil. Five is Nur Uzma Afrina binti Hasramani. And lastly, Wang Chingkang. Okay, for our introduction, okay, digital filter is a system in the signal processing that conduct mathematical operation on a sample. This create time signal to decrease or change specific characteristic of that signal. Okay, next. A digital filter system is typically include an analog to a digital converter ADC to sample the input signal. Okay, next. Digital filter are more costly than analog filter because to their much higher complexity. The next, digital filter may indeed be designed and assembled, but mostly in finite path response filter and enable a linear phase response. Okay, lastly, digital filter are also suited for adaptive filtering application. Okay, next, I will pass to our group's members.
Hi, Doctor. My name is Wong Jin Kang. Can call me CK. My matching number is AE1801110. And now I will do the presentation for the part objective. Okay, in our project got four objectives. The first one is to understand the theory of digital filter and apply the knowledge of the theory in response to the operation of digital signal. The second is to analyze the output signal and estimate the spectrum of the signal by applying the theory of digital filter. The third one is to identify the type of filter used of the spectrum. And the last one is to be able to demonstrate the simulation of the coding on the MATLAB software. That's all my presentation for objective part, and my friend will continue to the presentation for methodology. That's all my presentation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afiq Izzuddin bin Syahrir and I'm from Group 2. Okay, today I would like to talk about methodology of our project. In this project, it describes on how to apply the project is organized and the flow of the steps in order to complete this project. The project has been complete in accordance with process and discussion to fulfill the project's objective while carrying out a project that was implemented. This methodology is vital to assist in the development of the project in greater detail, including methods and procedure for planning, collection data, and writing descriptions of the project process. Okay, so this is the block diagram of our project. First, the step is the process of determining the spectrum by using MATLAB software. Next, the process in acquire of output signal of the filter system. Next, the performance evaluation of the type of filter use. Okay, so this is the flowchart of our project. And first start, then digital signal processing study. After that, we will build a coding and simulate and testing using MATLAB. After getting the result, if the results are saying no, so we need to start over the step before, and if the result is yes, we can get the result analysis and over. And okay, so that's all from me. Thank you.
Next, my name is Nur Uzma Afrina binti Hasramani. I will be presenting about the methodology of the block diagram. The signal output was obtained by applying the data in Microsoft Excel based on the block diagram that was used in the project. The project was carried out with the exists from the MATLAB, which is for numerical computation. As a consequence, this MATLAB software is being used to solve the problem in this project so easily, which at the same time the idea of combines interface programming, visualization, and even computing. The first block diagram is the process of determining the spectrum by using MATLAB software. This project is developing for the program of MATLAB and design the standard test signal processing. We use the MATLAB system to analyze the coding of spectrum Fourier transform model. Then we use a graph from simulation to see whether our variable were correct or not, and then we will produce the amplitude, time, magnitude, and also phase. MATLAB also has a filter direct command that may be used to develop linear digital filters. We will also compute and acquire the simulation result, which include the data input signal, filter data, and spectrum input data. Next, for the second block, is the process in acquire of the output signal of the filter system. We shall illustrate a digital processing approach in a digital signal processing application, and then we should also filter the supplied signal that use the given filter response. Then we use MATLAB software to produce a graph based on the value supplied in Excel, which is where the sampling rate is 13, and the sample time interval is computed by using the basic formula 1/fs by depending on the signal Sn. We will also determine the outcome by also determine that the outcome Yn signal graph is the filter system's output signal graph while using the given Hz response filter. For another block is the performance evaluation of the type of filter used. We will apply the type of filter within this project, that is the bandpass filter. We can define that the graph also as a bandpass filter, which is the type of filter by plotting the filter magnitude and phase spectrum versus time, which the difference between the input data signal and the filter data signal by using the MATLAB software. Bandpass filter have included as well at least two processes variables, which are one for the bandwidth adjustment and another for band is for the position. The data processing would then be necessary to help recover the complex and varied spectrum of the input in order to regain the outband frequency. The bandpass filter demonstrated the input signal through the frequency of 2 Hz, 28 Hz, 6 Hz, 24 Hz, 10 Hz, as well as and 20 Hz have a comparable amplitude as a result of the graph data signal input Sn of phase magnitude spectrum in respect of time and the output filter signal as Yn of phase and magnitude spectrum in respect to the time data signal.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Amsyah Fahmi bin Asmadi. My matrix number is DE190206. I, as a member of Group 2, will be presenter for the result and analysis. Before we go to the result analysis, firstly, I would like to demonstrate my MATLAB coding for this project. Before we simulate this MATLAB coding project, we need to see what the question asks. Okay, for the first question, the question asks to plot the signal and determine its pattern by using the digital signal generated using a computer. This is our, because our group is our group 2, this is our data input for us to plot the signal and determine the spectrum. Next, question number 2 is to calculate the output signal of the filter system. This is the filter system that we given. Number 3 is to estimate the spectrum of the filter signal in question 2. And number 4, we need to know and identify the type of filter that used based on the result that we get. Now, I will show my MATLAB coding for this project. For the question 1, we need to generate that signal given. This is our digital signal given for group 2, and we need to estimate the spectral Fourier transform for the signal that we given. Then for the question 2, we need to apply the filter given. This is the filter that given to our group, and to find the filter for the digital signal for the question 1. Then for the question 3, we need to estimate the spectral Fourier transform based on the question 2. Okay, this is the coding for the difference between input data and filtered data, and this is the coding for the difference between spectral input data and filtered data. Next, I will run the coding. Okay, for the first question for this figure of graph of amplitude versus time, based on the signal as n above, we use MATLAB software to create the graph based on the value that provided in the Excel before, where the value of the sampling rate is 30 and the sample time interval is calculated using formula 1 over S. So that we can see that the signal that we given is unstable. Next, for the question 2, uh, the signal Sn is modified using the fast Fourier transform method to produce a graph of amplitude and phase spectrum versus time, as shown in this figure. Both magnitude and phase graph demonstrate a signal is instability. Next, for the question 2, we need to apply the filter given. Okay, this is the output that we get after we apply the filter given. The result of signal Yn is the output of the signal graph utilizing the supply HZ response filter, as shown in this figure. Time has an impact on the amplitude. The amplitude value is more constant most constant after the longer the time. As the result, the signal of Yn is more stable. Okay, next for the question number 3, what we need to do is we need to estimate the spectrum from question number 2. Okay, this is the signal from the question 2 is modified using the fast Fourier transform method to produce the output graph of amplitude and phase spectrum versus time, as shown in this figure. Both magnitude and phase graphs demonstrate is more stable uh, than the spectrum Fourier transform from the question 1. Okay, for the question 4, we need to determine the type of filter we use based on the result. Okay, based on the result of MATLAB from the previous question, the type of filter used in this project is the band pass filter. Okay, for the figure 5, this is the analysis of the difference between input data signal and filtered data signal. We can identify the graph as a band pass filter type of filter based on the previous figure of graph of filtered magnitude and phase spectrum against time that we acquire, because it has a 2RC filter derived from the mixture of the high pass filter and low pass filter. The band pass filter is classified as the second order filter. The filter can be used to cut the low and high frequency and standardize the signal. A band pass filter output signal is frequently smaller than the input signal. This figure show a graph of the input of filtered data signal with the input data signal having a greater amplitude than the filtered data signal. Next, for the analysis of the differences between spectral input data and filtered data, based on this figure, input data signal Sn of magnitude and phase spectrum against time, and output filter as signal Yn of magnitude and phase spectrum against time data at the frequency 2 Hz and 28 Hz, 6 Hz, 6 Hz and 24 Hz and 10 Hz and 20 Hz. The input signal of the filter illustrate has equal amplitude. The output amplitude of 2 Hz and 28 Hz, also 10 Hz and 20 Hz, is greatly reduced after going through the band pass filter since they are beyond the required frequency range. However, the frequency at the 6 Hz and 24 Hz is inside the desired range. Therefore, the signal amplitude is only little affected. Okay, I think that's all from me for result and analysis. Thank you.
Assalamualaikum, my name is Adila Faria binti Zainal, and now I will present on the conclusion part. This project simulation was done by using MATLAB simulation by inserting the digital signal given and the sampling time. As for the result, it showed that spectrum refer to the signal frequency, contain both phase and amplitude. A time series or one-dimensional signal represent the present or non-present of the different gradient of the time domain signal. Next, this project helped us to get better understanding on how to obtain the output signal of the filter system. By applying the filter response to the mathematical operation, we can receive both amplitude and phase signal. This digital filtering is not only a smoothing or averaging operation, but also any processing of the input signal. Then, the digital filter give advantage in terms of high accuracy, high noise immunity, and also easy modification filter characteristic. Last but not least, we can also get to know better about the band pass filter, which only allows those frequency within a particular band to pass through. Band pass filter also enhance to the signal to noise ratio in a receiver. This is because it has two cut-off frequency, which is lower frequency and higher frequency, and also eliminating any signal outside this frequency. That's all. Thank you.